In number 18, we're squaring a complex number. Now this is going to be just like squaring two terms. So just as a reminder now, let's do this. All right, just as a reminder. If we had something like this, say we had x plus 5 squared. Do you remember our template for this? We just talk our way through it. We square the first, getting x squared. Then we multiply these two together, 5x, and double it. So you square the first, multiply these two, and double it. So 5x doubled is going to give us 10x. And then you square the last, plus 25. So that's our template. So what you do is you square the first, multiply the two together, double it, square the last. So let's do that here. And what we're going to keep in mind now is a couple of things here. We're going to keep in mind that I squared, let's see if I can get it to right. I squared is -1. So when I see an I squared, I'm going to think -1, and -1 times anything just changes that thing's sign. So let's see where we go with this. So bring it down here. So square the first. I'll get a 9. Multiply these two terms together. Positive times negative is -12i. Double it, minus 24i. And square the last. Now when you square this, -4i times -4i is positive 16i squared. But I squared is -1, right? That's a -1. So we're going to get 9 minus 24i plus 16 times I squared, but I squared is -1. 16 times -1 right here is -16. So I get 9 minus 24 minus 16. And then I can, there's an I there. And then 9 minus 16 is -7 minus 24i. Now this step here I can actually skip. I know I squared is -1, and when you multiply any number by -1, it changes its sign, right? Positive 16 times -1 goes to -16. So as soon as I see this, I squared, I skip this step and I go right down here. I got positive 16, I squared, sign changer. So see, I squared is a sign changer. Positive 16, change the sign, -16. 9 minus 16 is the -7, minus the 24i. Now let's just multiply this number by this number, just as if they were two algebraic expressions, binomials. So we'll multiply everything in one by everything in the other. So how about first times first? That'll give us 14. And then the outer product, 2 times -4i, will give us minus 8i. Now we've run the 2 through, so go over to the 3. So 3i times 7. Positive 3i times positive 7 is plus 21i. And then the last, 3i times -4i is minus 12i squared. Now we can combine these. What was that? We can combine these right here. So I'll get 14. Now, -8i plus 21i is 13i plus 13i. And here's that I squared. Now you could put -1 here, then -12 times -1 is 12, or just see it as a sign changer. -12, sign change, positive 12. And then the 14 and the 12 is going to give us a 26, and then the plus 13i. In number 20, we've got a complex number divided by a complex number, and we're going to handle these the same way we did like rationalizing denominators when we had radicals. So this is going to be similar to, let me see it, problem number 14, in the sense that what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the bottom. I went blank for a minute. So I'm going to multiply by 1, but that 1 is going to be the conjugate of the top of the bottom here. So let's write that. We're going to have 3 plus I over 2 plus 5i times, now, just take the conjugate of this, of that denominator. So how about 2 minus 5i, 2 minus 5i. Now let's multiply. So I'm going to multiply completely through in the top. So 3 times 2 is a 6. Then 3 times negative 5i is minus 15i. So I ran the 3 all the way through. Now come to the I. I times 2 is 2i, so I'll get a plus 2i, right? It's positive I times positive 2, so 2i. And then I times negative 5i is negative 5i squared, minus 5i squared, all over. Now, these are conjugates. We know what to do with conjugates. You square the first, getting a 4, put a minus sign, and square the last. 5i times 5i is 25i squared.